Continuing with exponents, we're going to look at 5.2, which we're going to be multiplying powers that have the same base. Powers that have the same base. So if we look at our first property we're going to be using, you see a to the m times a to the n is equal to a to the m plus n. So all you're really doing when you have the same base, meaning the same number, the same variable, you just take these two exponents and you add them together. This is not an addition problem, this is a multiplication problem, but just you solve or you simplify by adding the exponents together. Now a is not 0 and m and n are rational numbers. Okay, so some examples, you have a base of 3 here and here, so when I multiply I can simply add the exponents together and you get 3 to the 5th power in simplified form. Now remember, 3 to the 2nd is just 2 3's, 3 to the 3rd is 3 3's, so if I multiply those together I get 5 3's, which is 3 to the 5th. Okay, when I have a variable base, as long as they're the same, you can simply add 5 and 7 and you get 12. You got 5x's here, 7x's here multiplied together, and you get 12x's multiplied together. Okay, and that's the first property. That is a multiplication of powers property. Now let's look at rational exponents. This is going to be new for us. Okay, notice here our exponent is a fraction. Okay, we're going to be specifically looking at the bottom number for this. When I have a number in the denominator, that is indicating a root. In this case, I have a 2 in the denominator, which is indicating a square root. So if I have a to the 1/2, that is the same as the square root of a. In other words, what number multiplied to itself equals a? Okay, so looking at this one, 9 to the 1/2 is the square root of 9, which is simply 3, because 3 times 3 is 9. The square root of 9 is 3. Now 8 to the 1/3 is the cubed root of 8. Okay, the 3 goes here, it's the cube root, not square root anymore. That means a number multiplied 3 times equals 8. What number is that? Well, 2 times 2 times 2 is 8, so 2 is the cubed root of 8. And that takes care of just the intro to what we're doing today. For the first example we're going to look at, we're going to be just simplifying powers that had bases that are numbers, not variables. Okay, so we're just going to look at 6 examples of these, and it should cover everything you should see. Okay, notice I have the same base here, here, and here. It's all multiplied together, so all I have to do according to the property is add the exponents together, and I keep the base the same. You do not multiply the base stays the same. So I get 9, so that's going to be 9 to the 14th if I add all the exponents together. You do not multiply these bases together because you've got 5 9s, 7 9s, and 2 9s. You've got 14 9s. You don't have 14 of something else. Okay? You don't have 14 of whatever 9 times 9 times 9 is. You don't multiply the bases, so you simply add the exponents here. Okay? Let's look at number 2. Number 2, notice all the bases are the same. So we simply add the exponents. I've got -5 and -2, which is -7. -7 plus 3 is -4. So initially I get -5 to the -4. Well, the negative on the exponent means put it in the bottom. Okay? In other words, take the reciprocal. So what I'm going to do is I'm going to flip it. And when I do that, I take the negative off the exponent. Now we can do one more thing to this, because that minus sign, I've got 4 to the power of 4 and it's a negative to the power of 4. That means it's actually going to be a positive number. So we actually get 1/5 to the 4th. We can take that negative off that because we have an even number of negatives. Okay, the next one, we have -3 and -5, which is -8, and +8, which is going to be 0. So I get 2 to the 0 power, and that simply equals 1. We learned that our last go around. Here I have two -2 bases. This is actually an exponent of 1. Okay, so I actually have -2 to the power of 3. And if I really wanted to be particular and simplify this, since I do have an odd number of negatives, it's going to be negative. I can simply write it without the parentheses, because that'll just cube the 2 and then put the negative on at the end. So it's going to be negative. So this is a little bit simpler form than this. Okay, here we have 7 to the negative 3 and 7 to the first. If I add those together, it's 7 to the negative 2. That is a 7, believe it or not. That means take the reciprocal, or you can think move it to the denominator. That means it's 1 over 7 squared. And we could do 1 over 49 if we wanted to, but we'll just leave it 1 over 7 squared. Okay, for the last one of this set of examples, we've got 3 bases that are 10. So I'm going to write that, 5. And we have negative 3 and negative 2, which is negative 5. 5 plus negative 5 is 0, so 10 to the 0 certainly equals 1. Okay, and that's simplifying numerical bases, In example 2, we're going to be simplifying powers with variable bases. Okay, so it's pretty close to the same thing we've just done in example 1. Notice I have the same base here. I don't have a dot here. I don't need a dot when they're together like this. It's multiplication. So if I multiply and I have the same base, I simply add the exponents. Okay, so that is x to the 8th power. A common mistake is to multiply these exponents, and we do not do that. When you multiply bases, you add exponents. That is an 8, believe it or not. Okay, let's go down this way. Now, here I have coefficients with my variable bases. So what you don't have to do this on paper, but you have to think of it this way. The coefficients all go together. The x's go together. And then the y's go together, and there's only one y. So what I'm simply doing here is I'm basically multiplying like things together. Okay, like things together. So if we look at this, that's 30 times 3, which is 90. We get 90 when we multiply those. When I multiply these, I add the exponents, I get x10. And then the y2 has nothing to change it, so it stays y2. And there we have it. Okay, looks kind of complicated, but it's really pretty simple. So again, you don't have to do this, but I'm just trying to show you that so you can think of it mentally. Here we want to put the numbers together, the coefficients, 5, 9, and 3. Then we have some x's that need to go together. I got negative x4, and I've got x1. Actually, there's a better way to handle this. Let me back this up. Okay, 5, 9, and 3. We're going to call this negative 1 coefficient, so we'll put the negative 1 with this group. Okay, then we'll have x4 and x together, and then we'll have r4 and r negative 7 together. Okay, so those are the like things. Okay, so we are going to be multiplying, let's see, we get 45, 45 times 3, that should be 135, and that's a negative 135. We're going to multiply those together and get that. Now x4 times x is really x4 times x1, which is x5. And then r4 times r negative 7 is r negative 3. Because it's a negative, we're going to put it on the bottom. And we will make it r3 on the bottom. That's a terrible r, but that's what it is. So I get negative 135 x5 over r3. Okay, over r3. Notice this negative makes the coefficient or the number, the expression negative. This negative simply means to put the r on the bottom. Okay, next set, now I'm not going to group them like I did these two. We're just going to multiply these numbers together. So we get 8 times 5 is 40, times 3 is 120. I want to write that down. Then let's do the x's. I get negative 3 and negative 5. Well, that's a negative 8. That means it needs to go on the bottom. So it's x8 on the bottom. Okay, add the exponents on the y's. We get 2 and negative 7, which is negative 5. That means put it on the bottom, y5. So the only thing I have on top is a 120. It's a little off center, but that's the way it is. Okay, next, okay, we have a coefficient of negative 1, 3, 6, and 2. So let's multiply the coefficients together. We've got 3 times 6 is 18. Times 2 is 36, and that's going to be a negative 36 when I multiply by 1. Okay, so the coefficients are done. And if you want to cross those out, you're more than welcome to if it helps. Okay, here we have a, we're going to put these a's together, here, here, and here. So that's 2 plus 2 is 4, and negative 1, negative 3 is going to be positive 1. So that's going to be a1, very ugly a1. And then b is by itself. There's no b with it, so we're just going to put b there by itself. And that's that. One more problem for this section. We've got the 3 and the 2. Multiply together, you get 6. Actually, we have a negative 1 here, so it's going to be a negative 6. Okay, I didn't see that. Okay, now here we've got a 4 on the x, a 3 on this x, and a negative 2 on this x, so we're putting these x's together. We get 7 minus 2 is 5, so it's going to be x5. Here we have a y1, and if it helps, please write that in when you're doing these problems. 5 plus 1 is 6, minus 2 is 4, so we get y4. Nothing in the denominator here, and that is that. Now we're going to look at some expressions with rational exponents. Okay, these don't really have to be hard. This one would be without a calculator, but I'm going to fix it so we can kind of do it without a calculator. We're going to change that 4 to a 2. Okay, before we do this. Now, it has a rational exponent. The bottom number is a root, so a square root. The top number is like a cube. Okay, so we're doing two things here. We're going to cube it and take the square root. Now with this one, it doesn't matter which one you do first. You could take the square root first and cube it, or cube it and then take the square root. You will get the same answer. Okay, so let's square root it first. So the square root of 4 is 2, and then if I cube it, that's going to be 2 times 2 times 2, and that is 8. Okay, and that is our answer. Let me show you, if we cube it first, we get 4 times 4 times 4, which is 64. And then the square root of 64 is 8. So you get the same answer whether you do this first or this first. So you got two things going on. You got what you think of as a regular exponent there, and here you have a square root. Okay? Okay, moving on to number 2. We have a fourth root of 256. Now, if this is too difficult, if you want to pull the calculator out, that's fine. You can put you can take the fourth root in your calculator, but that's just taking the square root twice. So if we take the fourth root of 256, we take the square root of that, we know we get 16, and then the square root of 16 is 4. Okay, so that is the fourth root of 256, and if we multiply it 4 times, we get 16 times 16, which is 256, and that gets our answer. That gets what we started with. So 4 is our answer. It's the fourth root of 16. That means a number multiplied by itself 4 times gives you that number. Okay, let's look at this one. Since this is 16, it'd probably be better to take the square root first instead of cubing first. So take the square root of 16, that's 4, and then that top number means to multiply it 3 times. So 4 times 4 is 16, times 4 is 64. Okay, so we get an answer, a final answer of 64. Again, we take the square root, which is 4, and then cube it. 4 times 4 is 16, times 4 is 64, and there's our final answer. Okay, here we're gonna cube, and we're gonna take the square root. I think we probably want to take the square root first. Okay, so if we take the square root of 9, we get 3. And then we get 3 times 3 times 3 when we cube that number, and we get 27. 3 times 3 is 9, times 3 is 27. Okay, now we're just going to simplify. These exponents are on variables, so we're not really going to have to do any of this right here. We're just going to simplify. Okay, so again, everything is multiplication. This isn't distributive property because there's no addition sign or anything like that. This is simply all multiplication. So we're going to take all the numbers and multiply them together. Okay, so we have 8 times 6, which is 48, times 2, which is 96, and then we have 96 times 4, which gives us 384. Okay, so we have 384 for our numbers. Let me check that again. Let's just 64 times 6, and yeah, we get 384. Okay, now we're going to put the x's together, and remember, when you multiply variables, when you multiply the same base, you add the exponents. So we're going to have an x to the 8 halves, okay, and then we're going to have y to the 8 eighths. And we can simplify these fractions. So our final answer is going to be 384 x to the 4th power, y to the 1st power. 8 over 8 is just 1, so it's y to the 1st power. Okay, that was actually pretty easy. Okay, let's look at this last one. Let's look at all these numbers multiplied together. We got 3 times 3 is 9, 2 times 5 is 10, 10 times 9 is 90. Okay, so we're going to go and write the 90 there. Let's look at the x's. Yeah, these will work out. So I got 1/3 and 4/3. That gives me 5/3. So it's going to be x to the 5/3. Okay, that's an exponent. I just wrote it kind of large. And let's look at the y's. Okay, we got y. We got 1/7, 3/7. That's going to be 4/7. Okay, so all we did was multiply the coefficients like we did earlier. And then we just added exponents on the same basis. And these are not going to be reduced. We're just going to leave them as is. And that takes care of this example. Okay, example 4, we're just going to find the missing exponent. Now these can be pretty simple. You just got to, they can be tricky every now and then, but for the most part they're pretty simple. Okay, so this first one we're going to look and see what this exponent has to be. Notice this, we have the same bases, so we have to add to get this. So 2 plus what is 11? Well, that's going to be 9. Okay, and so the exponent is 9. If you want to, you can certainly write 9 to the 9th power, but we're just looking for that exponent, so you don't have to have that. We just need a 9 there. Okay, let's look at number 2. 3/4 plus what is 7/8? Well, let's look at this. To get this, you need to subtract this and this. So 7/8 minus 3/4, well, that's going to be 7/8 minus 6/8 when I get a common denominator, which is 1/8. So this is simply 1/8. And I won't write it with the x. I'll just write 1/8 for the answer. Okay, again, to get this number, you simply subtract this and this. Like we did here, 11 minus 2 is 9, 7/8 minus 3/4. We had to get a common denominator, but we got 1/8 out of that for an answer. Okay, now here, notice the y in our answer has an exponent of 1, and there's only one y over here, so this first question mark has to be a 1, because there's no other y to change that. Now notice the x has an exponent of 5, we have an x with an exponent of 2, and then a blank here. 5 minus 2 is 3. So this exponent was 1 for the y, and this exponent was 3 for the x. Okay, now notice here our final answer is 1. That means we got to have a bunch of exponents with 0. Okay, we got final exponent had to be 0. So I have to have y to the 0, x to the 0 to get a final answer of 1. Well, to get y to the 0, there's only one y, so this first exponent has to be 0. To get x to the 0, I've got a 3 here. I need that to be a -3, so when I add that to that, it becomes 0. So what I get when I do that, I get x 0, y 0, and that simply equals 1. Okay, and that's completing the equation or filling in the blanks. It may have been a while for most of us doing scientific notation. So just a reminder, with scientific notation, this is a multiplication sign. This number is a number greater than or equal to 1 but less than 10. And this is always 10 because these are, you're multiplying numbers by powers of 10. So this is always 10, and this is an integer exponent, okay? Not rational exponents, but an integer exponent. Okay, so what we have is a number in scientific notation multiplied to another number in scientific notation. So again, kind of like the coefficients and the variables, you do this the same way. You put like things together. So we're going to take the 2 and the 3 and multiply them. Then we're going to take the 10, -2 and 10, -2 and multiply those. And we're going to write our final answer in scientific notation. So 2 times 3 is 6. I write that. -2 and -2 is -4. Now the beautiful thing about this is when you have negative exponents with scientific notation, you don't have to flip it or do anything like that. You just write the negative exponent. Okay, so our final answer here is 6 times 10 to the -4. That's it. We multiplied like things together. Let's look at this one. I know it's 2's down here, but let's go this way. Okay, so I'm going to multiply the 3's together, and then the 10, 4 and the 10, 3 together. Okay, so 3 times 3 is 9. Put the multiplication sign between the two, and I get 10 to the 7th power, okay, for that one. Okay, let's see if we can scroll down a little bit this way and get rid of those. Okay, next one, I'm going to put the 8 and the 4 together, and I've got the 10, 6 and 10, -12 together. Okay, well, 8 times 4 is 32. Times 10, we're going to add these together, we get -6. Now here's a problem. Okay, this number right here is bigger than 10. I can't leave it that way because it's not truly in scientific notation, so that number's between greater than or equal to 1 and less than 10. So what I have to do is take the decimal that's here and move it one place this way to give me 3.2. Okay? Now, to fix that, I can't just make that change and keep that exponent the same. The exponent is telling you or telling someone how many times the decimal's moved. Well, if I move it another place, I have to change that exponent. So basically, you have to balance it out. And the way I get people to think of it, if I make this number smaller, to get the same answer when I multiply, I have to make the exponent larger. So if I move it one way to make it smaller, I've got to make this one larger. So one larger would be -5. Okay? So 32 to the -6 is the same as 3.2 to the -5. Now this is okay because it's in scientific notation. Okay, everything works. Let's look at this one. We're going to multiply the 0.3 and the 2 together. We get 0.6 or 0.6. So I'll just leave it 0.6. Okay? And times 10, we get 2 plus -6. You're not multiplying. Don't forget that. You're adding. So you get -4. Once again, I have a number here that needs fixed. This is less than 1. I need to make it larger than 1. Okay? Greater than or equal to 1. So I'm going to take this and move the decimal one place this way and make it 6. Okay? If I do that, I have to fix the exponent. Okay, remember this is a product, 0.6 times 10 to the -4. Well, if I make this number bigger and I want the same product, I've got to make this exponent smaller. So I moved it one place, made that bigger, moved that one place down. That becomes -5. Remember, we're going away from 0 to make it smaller. Okay, so 6 times 10 to the -5 is my final answer. Okay, let's look at this. 0.6 and 0.2, well, that is going to be 0.12. Okay, 0.12. And then we have 10 to the 5th times 10 to the 4th, which is 10 to the 9th. We have to fix this. Okay, I'm going to move this decimal from here to here and make that 1.2. Now, I made that number bigger, so to balance this out, I have to make that number smaller. Okay, so that is going to be 10 to the 8th. 1.2 times 10 to the 8th. One more of these. 8 times 9 is 72. 10.2 times 10.4 is going to be 10.6 because you're adding the exponents. Okay, again, I want to make this number less than 10, so I'm going to move the decimal from here to here. I'm going to make that smaller. So to balance this out, I've got to make that bigger, larger. So I move that one place this way. I move that up 1. That makes it 7. So 7.2 times 10 to the 7th. And that rounds out our scientific notation section. This is our last set. This is example 6, and we're just going to simplify some maybe a little bit more difficult problems. Let's look at each. Okay. So number 1, we're simplifying. There's nothing to simplify up here, but notice down here I've got bases that are the same. So initially when I simplify this, I add the exponents. I get -2, right? But the negative tells me to move it, tells me it's in the wrong position, tells me to flip it, take the reciprocal. So basically I'm going to get x squared. I'm just moving this to the top, and when I do that I get x squared. Okay, so this is the simplified version of that. Let's look at this one. Okay, we're going to just take this and distribute and write our answer. Well, when I distribute, -2 times 4 is -8. And then x2 and x1 give me x3. Okay, that's a 3. For the next one, I get -2 times -8. It's going to be a +16. And there's nothing to multiply the x2 by, so the x2 stays the same. Okay, and that's it. Okay, here we've got 9 times 9x to the x times 9 to the x minus 4 times 9 to the third. Well, what that is basically 9, and we're adding all these together, so it's x plus x minus 4 plus 3. Now we're going to simplify it, obviously, because that's kind of a mess. So I can add the like terms together. I get 2x minus 1. -4 and +3 is -1, so I get 9 to the 2x minus 1, and I can leave that there. We don't know that this whole thing's negative, even though there's a minus sign here, so we're not going to do anything with it. We just leave it like this, 9 to the 2x minus 1. Okay, let's look at this one. we got different bases, so I'm going to look at the 2's first, and I'm going to add those together. So 3 plus a half is just 3 and 1/2, but I want to make that improper. So if I take 3 and 1/2 and make that improper, that's going to be 7/2. Okay, so it's going to be 2 with a 7/2 exponent. And then we're going to look at the 3. What should that be? Well, I've got 2x here and y here, and they're different. They're not like terms, so it's just 2x plus y for an exponent. Okay, looks crazy, but that's all it is. You add this to this, they're not like terms, you've got to keep them separated. Okay, 2 to the 7/2 times 3 to the 2x plus y. Now if we really wanted to, we could simplify this. I'm not really into that right now, but we're just going to move on. Okay, here I have the same base here as I do here. Okay, x minus 2 and x minus 2 are the same base, so I simply add the exponents together, and I get x minus 2 to the 6th power. Okay? And that's pretty simple. That's a 6. It's an ugly 6. And that has it. That sums up the lesson. That's our last example. I hope this was helpful.